are in AP with increment R. Increment, I think they mean to say that common difference. Then the difference between mean of their squares and square of their mean is, dear all, this question if you will do by taking A1, A2, AN, it can be difficult, but let me tell you, if you understand the concept of variance, variance of some data is nothing but what they are asking here. It is actually mean of the squares. It is mean of the square means sigma AI square upon n minus sigma AI upon n whole square. This is what variance is. That's a very standard concept. It is done in 11th standard where mean variance is taught. So you should know. And there is one very important property, let me tell you. Actually, this result is a shortcut to find this variance. In fact, we in the beginning defined this variance as sigma of AI minus A bar. A bar means the mean of the data square upon n. So it can be proved that this expression and this expression, they both are equal. It is just simple, you just have to open this bracket, it can be proved. Okay, now because of this thing, there is one very important property of this, that if you decrease or increase your data by same number, your variance doesn't change. So if I am looking for variance of A1, A2 and so on, AN, and if I reduce every data by same number, my variance will not change. Why it is so? Because if you reduce every data by same number, your mean will also change by the same number. So every AI and A bar, they are reduced by same number, then their difference will also not be changed. So variance, whether you find A1, find for A1, A2, AN, or you find for another data which we have obtained from this A1, A2, AN only, but by subtracting by a fixed number. For example, if I subtract this every data, subtract by A1 minus R. Why I have done A1 minus R, you will very soon come to know. If I subtract every data by A1 minus R, I think this one will become R, first one. A2 will become 2R, yes or no? Because A2 minus A1 plus R, so it will be 2R. Next it would be 3R and so on, and then the last one will be NR, you can check. So actually we have to find this variance of this data for R, 2R, 3R and so on NR. In fact, R can be taken common, okay, and this in this variance it will come as R square outside. Okay, so let us see how this will be done. Let me write this data once again. So my data is actually, or rather I should say my modified data is now R, 2R, 3R and so on and NR. So now variance of this data will be, we can write this as sigma of actually mean of their squares. Mean of their squares means you can add their squares by taking R square common, and then it is just the sum of squares of first n natural numbers, which would be n into n plus 1 into 2n plus 1. In fact, I have already taken the sigma, so the sigma is not needed. You can check, this is actually the sum of squares of all these numbers, because R square has been taken, then it is the sum of squares of first n natural numbers. I think divided by 6 will also be there. And if I have to take the mean of these squares, I will be dividing it by n, because these are n in number. And I will be subtracting the square of their means. Square of their means, first mean, what will be the mean? The sum of all these data will be R common, n into n plus 1 by 2, that will be the sum of all these data, and mean I have to subtract divide by n, and then I have to do the square of this. So this is what I am looking for. So here you can see this n will cancel this n here, this n will be cancelling this n here. I can take R square common, I can also take 12 common. So R square upon 12 if I have taken common, and also I think n plus 1 can be taken common. Then what I'll be now left with, I think I'll be left with 2 into 2n plus 1 here minus 3 times n plus 1 here. So you will be getting r square into n square minus 1 upon 12. This is 4n minus 3n n minus 1. So answer will be C. We are all, this question could have been done directly without doing anything. Why I am saying so? Suppose I am having only one data A1, which means n is 1. Okay. Now if only data is A1, its square of means, its a mean of squares or square of means will be same thing. So your value has to be 0, isn't it? For n is equal to 1, if it is 0, so answer will be either C or it will be D. If it is D, then it is independent of R. Okay, now maybe you can do one thing, you can take n is equal to 2 and you can take A1 and A1 plus R, and then you can do the calculation, you can check that it is dependent upon R, so answer will be C, not D. So this is how it could have been done, although this question, the reasoning behind, or the whosoever made this question, he would have thought of this property of variance while making this question. So this was not easy question, I will say, because if you start doing this question by writing that first my AI would be A1 plus I minus 1 into R, and then doing the square and then taking the sigma, it will become a huge question. Okay, so I think you are getting what I'm trying to say.